Now we have discussed magnification, derivation of magnification formula. So what is that? So magnification is the ratio of height of the image to the height of the object. Okay, it is also ratio of image distance to the object distance. Okay, we have derived this formula just previously, right? Now we are going to talk about magnification of the concave mirror. See, generally we place the object in front of the concave mirror at various positions. For example, if you take this is a concave mirror, pole, focus, center of the curvature. Okay, we will place the object beyond the center of the curvature. This is first option. At C, between focus and center of the curvature. At focus, between pole and focus. Whenever the position of the object changes in front of the concave mirror, the characteristics of image formed also changes. Also, the magnification value also changes. So what are the magnification values? When you place beyond C, at C, between F and C, at focus, between pole and focus, one by one we will discuss. Okay. Now, for example, first position of the object is beyond C. This is position of the object. Okay. Next, we discuss position of image. Next, characteristics of image. Finally, a magnification value. Okay, we are going to discuss one by one. Let's say object is placed beyond center of the curvature. Let's say here object is placed beyond center of the curvature. Until my explanation finished, okay, you consider the height of the object. This is height of the object. Okay, this height of the object is 10 centimeters now. What is the height of the object? Until my explanation finished, you consider the height of the object is 10 centimeter. Okay. When object is placed beyond C, when you draw the rules, or when you draw the ray diagram, where do you get the image? You get the image between F and C. When object is beyond C, what is the position of the image? Between F and C. Focus and center of the curvature. What are the characteristics of this image? This image is diminished. Why? The size of the image is smaller than size of the object. That is why it is diminished. This image is a real image. Why it is called real image? Because the rays which are incident from the object, okay, after reflection, rays are converging. If the rays converge after reflection, it gives you real image. Okay, real image. And where does this image form? Is it from upward the principal axis or downward the principal axis? Downward the principal axis. If the image form downward the principal axis, what is this called? Inverted image. Not upright, inverted image. Okay, so these are the characteristics of the image. This is okay, good. Now we are going to find the magnification value. So here we have height of the object and height of the image. So that is why I am using this formula. Okay, so magnification is equal to height of the image to the height of the object. Okay, here object, height of the object, it is 10 centimeters. It is fixed, there is no change. Okay. Now, height of the image. You see the diagram. This is 10 centimeters. Image is diminished. Means size of the height of the image is smaller than height of the object. What is the height of the object? 10 centimeters. Then height of the image should be less than 10 centimeters or equal to 10 centimeters. Less than 10 centimeters. Okay. Tell me any number less than 10 centimeters. Your wish. For example, you said 8 centimeters. If it is 8 centimeter, if I write 8 centimeter, but according to sign convention, image is formed below the principal axis, so I have to take negative sign. Okay, 8 by 10 is equal to how much, Nana? 0.8 minus by plus what, Nana? Minus 0.8. Okay, Okay. Or one of the student said 5 centimeters. The height of the image is 5 centimeter. If I write 5 centimeter, 5 centimeter, height of the object how much? 10 centimeter. This is 10 centimeter and this is 5 centimeter. But according to sign convention, that this is positive, this is negative. I take negative. So 5 by 10 is equal to how much? 0.5. Minus by plus minus. Minus 0.5. And some students will say this is 3 centimeter. So if I take this is 3 centimeter, height of the object is how much? 10 centimeter. 3 by 10. Okay? It is nothing but minus 3. Okay? Why I am taking this minus? Because image is real and formed below the principal axis. That is why I am taking sign convention negative. Okay? Right. According to third sign convention, any height of the object or images measured upward principal axis, sign to be taken positive. Downwards the principal axis, sign to be taken negative. It is downward the principal axis, so sign to be taken negative. Here object is upward the principal axis, that is why sign is positive. So every time we are getting these values. Where are these values generally lie between them? Okay, minus 0.3. Where are these values are lie between them? Okay, I will draw the number line here. This is a number line. This is 0. This is plus 1. This is plus 2. This is plus 3. This is minus 1. This is minus 2. This is minus 3. Like this. Okay. Minus 0.8. Where do you find this minus 0.8? Between 0 and minus 1. Minus 0.5. Where do you find minus 0.5? Between 0 and minus 1. Minus 0.3. Where do you find it? Also between 0 and minus 1. So from this, what do you understand? Whenever his object is placed beyond the center of the curvature, the magnification value is always lies between 0 and minus 1. 0 and minus 1. Not equal to 0, not equal to minus 1. Between the 0 and minus 1, any value is possible. Okay? Right. Now, I am going to keep the object at the center of the curvature. Position of the object I am going to change now. At the center of the curvature. When object is placed at the center of the curvature, what is the height of the object we are taking? The height of the object is, this is object, that is we are taking as 10 centimeters. It is fixed. When object is at C, image also forms at C with the same height and the same size. Okay. Now, when object is at C, where does the image form? Also at C. When you draw the ray diagram, already ray diagram is finished. The ray passes parallel to the principal axis after reflection passes through focus. The ray passes through focus after reflection parallel to the principal. They are meeting here. So the image is formed at C. What are the characteristics now? Size is same. So we have to write same size. Is it real image? Yes. After reflection, rays are converging. This image is formed due to the converging of the reflector light rays. So it's a real image. What is the real image definition? If the image is formed due to the converging light rays after reflection, that is real. Yes, the rays incident this way. One is incident this way, one is incident this way. After reflection, they are meeting here. They are converging. They are converging. That is very real. Next. And one more character. Is this image formed upward the principal axis or downward the principal axis? Downward. Okay. Upward principal axis, this is upright image. Downward principal axis, inverted image. Inverted. Characters finished. Now magnification value we are going to find. So height of the image is 10 centimeters. Height of the object also 10 centimeters, but according to sign convention this is negative. Okay, minus by plus minus, 10 by 10 1. So what is the magnification value? Minus 1, because height of the object is equal to height of the image. Okay, height of the object is equal to height of the image. That is why we get 1. When numerator and denominator is same, what do we get? 1, but minus by plus is equal to minus 1. If you take this height of the object is 5 centimeters, Then same size, no? When object is at C, image also at C, same size. Means this also will be 5 centimeters. Okay? Then you will get -1. If you take the height of the object to 20 centimeter, image also same size. So that is 20 and this is also 20. Okay? Again you will get -1. Whatever the height of the object, when you place at C, that image formed with the same size. If the height of the object is 20, image of the object also 20. If the height of the object is 5, image of the object also 5. If the height of the object is 10 centimeter, height of the image also 10 centimeter. So from this, what do you understand? Magnification value is always equal to -1. Okay? Always equal to -1. When object is placed at C, magnification value is always -1. Remember, in board exam, the question come like this. Draw the ray diagram for an image produced by the concave mirror, okay, with magnification value -1, or the magnification value of the image produced by the concave mirror is -1. Draw the ray diagram. Okay, so which diagram will you draw? Where do you place the object? Beyond C, at C, between F and C, where do you place the object? That is why you have to remember the values. If the magnification value is -1, that object compulsory should be placed at center of the curvature. At that point only we get the magnification value -1. If you place the object beyond C, what magnification values you get? Between 0 and -1, any number is possible. -0.5, -0.3, -0.4, -0.5, -0.6. Any number is possible. But not equal to 0, not equal to -1. Between that two. So that is why you have to learn these. Whenever object is placed at different positions, different magnification values we are getting. In exams, they will ask you to draw the ray diagram with these magnification value also. That is why you have to learn all these. Now, between F and C, object is placed between focus and center of the curvature. So now I am going to keep the object between focus and center of the curvature. If you draw the ray diagrams, we get the image beyond the center of the curvature. This is image. Okay. So our height of the object is 10 centimeters. So what is the height of the object we have taken? 10 centimeter. Right. Object is placed between focus and center of the curvature. Then what is the position of the image? Image formed beyond C. Beyond C. What are the characteristics of this image? Is this height of the image is equal to the height of the object? Is it smaller than the height of the object? No, it is bigger, larger, taller than this height of the object. So we say enlarged, or also we can say magnified. And one more. Is it a real image or virtual image? This image is formed due to the converging of reflected light rays. So it's a real image. And one more. Where does this image form? Is it formed upward the principal axis or downward the principal axis? Downward the principal axis. If the image is formed downward the principal axis, inverted image. Now we are going to find the magnification value. That purpose I am using this formula, height of the image by height of the object. Height of the object is fixed. I have taken 10 centimeters. Now what is the height of the image? You see the height of the image and height of the object. Compare it. Height of the image is greater than height of the object. So height of the object, how much we have taken? 10. Then height of the image compulsory greater than 10. Because height of the image is greater than height of the object. That is why it must be greater than 10. Yes or no? So greater than 10. Any value you tell me, just tell me yourself. 12, 15, 18. I will take all those values. If I take 12 centimeters, but image is formed below the principal axis, sign to be taken negative. Okay. So 12 by 10, minus 1.2. If I take this height of the image is 15 centimeters, okay, height of the object is 10 centimeters, then answer will be minus 1.5. If you take this is height of the image is 18 centimeters, height of the object is 10 centimeter, height of the image is 18 centimeter, but according to sign convention this is negative, then minus 1.8. So where do all these numbers lie? Minus 1.2 is greater than, less than minus 1, less than minus 1. Minus 1.5 also less than minus 1. Minus 1.8 also less than minus 1. If you take this is 10, if you take this is 30 centimeter, height of the image is 30 centimeters, minus 30 by 10 centimeters, your answer is minus 3. Magnification value is minus 3. So where does the minus 3? Minus 3 is less than minus 1. So from this what do you understand? When you place the object between focus and center of the curvature, what is the magnification value? Always less than minus 1. So what is less than minus 1? Any value is possible. 1 point, minus 1.2, minus 1.3, minus 2, minus 2.5, minus 3, minus 7, minus 10, minus 2.5, minus 3.47, anything. Any number which is less than minus 1 is possible. Now I am going to place the object at focus. When I place the object at focus, we know that ray passes parallel to the principal axis after reflection passes through focus. Okay, the ray hitting the pole after reflection make the same angle. So these are parallel. Okay, so image forms at infinity, or this rule also can be taken. The ray passes through center of the curvature, traces the same path. You see, you take this rule also. So you see now all are parallel beam. Do they meet? No, they do not meet. Where does the image form? At infinity. Okay. So what is the height of the image? Image forms at infinity when you extend this incident ray, the principal axis. When you extend this rays, image forms at infinity. So we can say highly enlarged. Okay. Technically mirror has to form the image, but in this case due to parallel rays, image does not form. Image form only when light rays converge or diverge. When we extend them, they meet. The rays are parallel. How do they get there? How do we get the image? But technically mirror should form the image. That is why we say this forms the image at infinity. Okay. For this case, magnification cannot be defined. Okay. So cannot be defined. Characteristics highly enlarged. Okay. Real. When object is at focus, where does the image form? At infinity. Image forms at infinity. So in some books, in our textbook, 10th class Telangana government textbook, we don't have the characters particularly at this position. In some textbooks we have real image and highly enlarged also we have. Right. So last one we are going to talk about. So beyond C finished, at C finished, between focus and center of the curvature, at focus finished, finally between pole and focus, object is placed between pole and focus. What is the height of the object? 10 centimeters. Let's say 10 centimeters. We are going to find the magnification formula, height of the image by height of the object. What is the height of the object value here? 10 centimeters. This object is upward principal axis, so positive. Okay, now where does the image form? According to a ray passes parallel to the principal axis after reflection passes through focus. A ray hitting the pole goes this way. Rays are diverging after reflection, so we have to extend them. Okay, image form here. This is the image, right? Image form here. Sir, this is virtual image. Image formed above the principal axis. When object is between pole and focus, where does the image form? Behind the mirror. What are the characteristics of this image? You see the size of the object, size of the image. Image is very bigger, enlarged. image is enlarged. This is formed upward the principal axis, so erect, and this is formed due to the diverging of the light rays. You see, after reflection, what is happening? Rays are diverging. Rays are diverging, not converging. If the rays converge after reflection, real image is formed. If the rays diverge after reflection, we get virtual image. These are the characters. Now we are going to find the magnification. So what is the height of the object? 10 centimeter. This is height of the image. Okay, if you take this is 10, how much it will be greater than 10? 20. Yes or no? 20 centimeters. This is above the principal axis, so sin to be taken plus 20 by 10, 2. What is the magnification value? 2. So height of the object we have taken 10 centimeters. Let's say height of the object we are taking 10 centimeters. Where is the image formed? Here. You see the height of the image, that is very bigger than height of the object. If you take this is 30 centimeter, when this is 10, if you assume this is 30, okay, 30 centimeters plus, both are plus, because this is also upward principal axis, image also upward principal axis, that is why sign convention is positive. 30 by 10 plus 3 plus 2. So magnification value plus 2 plus 3 plus 4. So where do you find this? Plus 2 plus 3 plus 4. All these are greater than plus 1. Okay. So always greater than, not equal to plus 1, but greater than plus 1. Not equal to plus 1, greater than plus 1. So greater than plus 1, any value is possible. Okay. And what is the conclusion we draw from here? This is very, very important thing. Here image is real. Here also real. Here also real. You see magnification values are minus, minus, minus. Less than minus 1 means minus 2, minus 3, minus 4, minus 2.5, minus 5, minus 6. Yes or no? If the image is real, magnification value is minus. If the image is virtual, magnification value is plus. So what is the conclusion from here? Okay. For real images, magnification is negative. For virtual images, magnification is positive. This is the conclusion. Yes or no? We got here plus value because image is virtual. We got here all minus values only because image is real. So for real images, magnification is negative. For virtual images, magnification is positive. Remember, because sometimes when we solve the problem, a concave mirror produces 3 times real image, 3 times virtual image. This kind of questions will come. 3 times means magnification. Magnification is 3. Real image means we have to take minus 3. Virtual image in the sense we have to take plus 3. Okay? So compulsory you have to learn this. In which case magnification is positive, in which case magnification is negative. Okay? It help us while doing the problems, solving the problems. Please note down this table properly. Okay? And learn these magnification values. Once again I repeat, when object is placed beyond C, magnification value is less than 0, 0 and minus 1. Lie between 0 and minus 1. Compulsory that value between these two, 0 and minus 1 only. When object is at C, magnification value always equal to minus 1. Always equal to minus 1. Equal to minus 1 exactly. When object is between focus and center of the curvature, magnification always less than minus 1. Less than minus 1, what are possible? Minus 2, minus 3, minus 2.5, minus 1.5, minus 3.5, minus 4, anything. At focus, we can't define magnification because image forms at infinity. Between pole and focus, magnification value is always greater than plus 1. Greater than plus 1. This plus 2, plus 3, plus 4, 2.5, plus 3.5. Okay, 1.5 also. Anything is possible. Okay? Remember the values, please.